All right. Hello, ladies and gentlemen. It's good. I'm not sure I've done this style of stream before. But this is supposed to be a very nice vibe, more like just geeking out and trying to do something fun. Let me just confirm real quick if my audio is actually geeking out and trying. Oh yeah, your audio is coming out good. Um, welcome to this camera. Welcome. My name is Ace, and today we're gonna be exploring what could it take for us if we were to build our own Jarvis rather. I don't think we can build end game level, or what's it called? Maybe Infinity War, maybe even Civil War. Actually, no. I don't think we can build Iron Man 3 and above level Jarvis yet. But everything before that, I think is already possible today with different kind of like tools, um, technology, inventions, models, AI tools, all of those things. So I spent some time last June just kind of like exploring what was possible based off what was available at the time. Oh, let me see. I thought this camera was ready. My bad. I was checking what was possible at the time to see if I could actually start to work on something like that. I never got around to working on it, but I did spend some time just thinking about it. And today, because the conversation came up on Twitter, let me see if I can share my screen. There was a conversation on Twitter around it like, hey, we should all build our own Jarvis. And I was like, I mean, yeah, I think we all should. I think we all should. Because, let me see if I can zoom in. Because imagine a world where we all had that smart personal assistant. I mean, we're not all Iron Man, but with the way it's going, at least with the existence of some local models, it's very possible and doable for us to actually get to that point. This is gonna be fun if you guys can also like say hello or just join in. So if you're watching, just say hello in chat, and then we can just brainstorm together and just have fun doing this. So I mentioned that I spent some time just planning, outlining, envisioning. If I was to make my own Jarvis in my own tiny office here, what could that possibly look like, right? So without further ado, let me see what we can do to. Let me see how we get started. I'm probably going to be using a Scali draw, but also just breaking down what the vision is in some sense of it. 1 second. So for most of it, right, many people assume that Jarvis as technology is that individual holographic device. But if you look at Iron Man 1, I have a video here that I'll show you guys real quick. Jarvis did not actually start out as that holographic entity, so to say. It kind of started out with just like a software device, or so am I saying, like software on a PC, on a computer, and then Iron Man was able to actually like just give you instructions. But the key thing was, regardless of what version it was very proactive. So we need to figure out a way that in today's world, can we make something that proactive? So let me show you guys real quick. I'm supposed to look at this in a way. Yeah, 1 second. This is a new setup. So let's take a look at what Jarvis looked like in the in the early days, right? Let's do this.
Jarvis, you up?
For you, sir, always.
I'd like
For you, sir, always. I always like that line.
to open a new project file, indexed as Mark II.
Shall I store this on the Stark Industries central data?
So if you pay some level of attention, yeah, this kind of environment, you can basically assume this is like some next level cloud setup, right? To an extent. Let me see. But I mean, it's a bit more than that.
Shall I
there
store
are additional devices here where he's able to like either use like a stylus pen or whatever, and then
this on the Stark Industries central database?
Actually, don't know who to trust right now.
So, but for Jarvis in his own right is confined. Jarvis in his own right is confined to that computer, and we can do that today with our existing, what's it called, software solutions. We can do that today. So there are 4 levels we need to think about. The first one will probably be the input, right? What kind of, let me see. The first one will most likely be like input. We need inputs. What kind of ways does our Jarvis, or in this case we can call it Loki, in what ways does it get information to process? That's going to be the input. And then we have the processing. we should also think about like the output, or before output actually. Let's say memory. Memory is key. It's often overlooked, but it's very very important as well. Oh, why is it not together? Delete memory. Are they still together? What's going on? Memory. How many times do I have to type memory for memory connect? Oh my days. Delete, delete, delete. So I don't even think I use a Scalio that much, guys. Memory. And then if you think about this, the input, the processing, the memory, and of course the key thing is also practice. God damn it. What's going on with this thing? Bye. Why is it so moving? But that's terrible. Anyways, where were we? So, if you look at today, what is an ideal structure for us to make a tool like Jarvis? We need to find a way that we can always speak to it, in a way that it can understand us, it can see, it can, of course, it can listen, it can see, and then also it can give us the output, both with audio or in a video format or anything that controls our computer, right? And one of the most important things in this regard are wearables. Can you guys see me? Let me see. Wearables, yeah, wearables. So I always assume that if I was going to make Jarvis, I would start with making it possible for me to speak over Bluetooth, for example, to maybe my PC that is running the software, that's running the Jarvis software. And one example of the Jarvis software could be an open source installation where, oh yeah, okay, now that I'm thinking about this makes sense. So let's start with processing. Processing in this case, how do I write text? Processing in this case includes AI agent. Should most likely be free to use. Should be local and installable / customizable. And for me, there was one tool that kind of fit into this, and at the time it was Goose. So all of this would fit into, or at least we're matched by, well, can you shortcut? We're matched by Goose. So if you don't know what Goose is an open source, what's the word? An open source AI agent that you can actually customize to match whatever it is that you want. So if I wanted my own custom UI, I could just go to Goose, do the download the code, fork the repository, customize it to fit any UI that I want, and then I install it on a separate computer that can be in my office. So if, let's say I have this other laptop, I don't know if you guys can see it. So if I install Goose on that laptop and I customize the UI to match what I want, I already have a level of, okay, this is an agent sitting on my device. I don't need this pages anymore. Let's bring this up here. So this is like a smart agent. Ooh, you guys probably can't see. My bad. Yeah. So for processing, this is our AI agent. It is free to use. It is local and installable or customizable. So I can do this with Goose, simply for the fact that it's open source. I think there are also other alternatives based on what we want anyway, so that we have full control. Like Open Code. Open Code is also open source. I've never used it, but Open Code is also open source, I believe. Yes, Open Code is open source. But Goose is the one I initially wanted to use. Like if I was setting this up, I just download Goose and then I have all of that open source goodies available for me to customize. Now, in the case of this processing, there are a bit of requirements here where how does it get proactive? Like that is very key. Before we even start thinking about how do we get information to it, how does it get proactive? Oh, sorry. I started playing music on my job. Oh God. Yes, how does it get proactive? That's where I discovered something called Goose Perception. Goose Perception is kind of like the way skills are today. And I think we might have slept on it, exactly. So Goose Perception was created by Mick. And what it does essentially is the exact, brilliant, we have this picture here. Yep. So what it does is, it has no GUI, it's processing in the background. It can be connected to your Goose, which is leading our processing. But it has, what's this English? Let me see if I can move this to the side for you guys. Can you see this? Yeah. So it's gonna know what apps you use. 1 second. I'm trying to reduce this so that you can see. Yeah, it's gonna know what apps you use. Doesn't wait to be told what to do, and it doesn't need chat or anything to actually start learning stuff. Which means it's very dependent on some. It has some memory structure where for everything it's learning about you day to day, it's storing all of these things in a markdown file in some structure. We'll get to memory in a second because that is also key in how you design this. But if you're able to figure out this goose perception structure, then it's able to take action by itself. It learns your preferences. It's observing what you are doing every single day. It's watching you, which means we also need some level of camera setup that is always visible or available in the office space. But with this overview today, if you're able to set this up, that kind of gives your AI agent, if you're starting with that, some level of proactivity where he sees what is going on and then he makes a decision on your behalf. Of course, there are security risks to that. They didn't talk about that in Iron Man. If Jarvis, just went off and was booking maybe flights or random stuff for Iron Man for Tony Stark, that would be a problem. I mean, you can remember in Iron Man 3, I think, where he booked the flight plan to Tennessee, and then I think emergencies happened. He didn't take the plane. He just boom flew directly to Tennessee. This is what happens when you give AI tools that level of autonomy, and it can make these decisions. But that's what we're trying to build today, barring the security issues that may arise. So, goose perception, when I saw it, can I drop this in chat? Maybe not. But when I saw goose perception, I was like, oh, damn, this is as close as it gets for an AI tool to just automatically just work in the background. And then most recently, we also saw CloudBot that was announced. I've not used CloudBot yet. There was a bunch of security vulnerabilities that was also mentioned in that regard. But with CloudBot, it's kind of the same thing, except that you speak with CloudBot over like text. So WhatsApp, Telegram, all of those things. But with Goose Perception, you basically just have it running in the background. Now, I've mentioned like we have a third party. One second, let's see. We have let's put it this way. We have like a third party computer or server that we install this thing on. So this is, in my case, it's going to be like my Windows laptop just to the side. And then we need to do with processing, which involves the AI agent. Let's see, the processing. Excuse me. So processing for us would be like, oh yeah, we have this AI agent here. It's going right under here. Let me see. Going to Goose. So Goose is going to be our AI agent, free to use. And then connected to that, it's going to be like, oh, we need some level of proactiveness, right? 1 second. So Goose. And then we need some proactiveness. How do I do this? Okay. 8. Proactiveness is Goose Perception. Now, for input itself, which is in this case, input, we need to think about variables, because that is where the brilliance exists. So if you have some level of variables where you have a Bluetooth headset, Bluetooth headphones. If I have Bluetooth headphones, even if I'm in my living room or what's it called, just moving around, I can speak to my device. Just something like, hey, let me see if you guys can hear this. Hey Meta, what's the time?
It's 6:17 p.m.
I don't know if you guys can hear that, but just having that kind of like connection, instead of staying in the glasses, the Bluetooth headphones connect to my PC. And or in this regard, if it doesn't connect to my PC, if I'm going mobile, then we introduce some kind of like Raspberry Pi. That's a different ball game. So if you want to go mobile, we need some level of Raspberry Pi that would have a Bluetooth connection. So even if it's just a Bluetooth earbud, connects to Raspberry Pi, and then our Raspberry Pi could connect to like a deployed server, right? So in this case, this processing tool is what's going to be deployed either to a third-party computer or a server. So the input, the Bluetooth headphones either connect directly. So the Bluetooth headphones or smart glasses. They could either connect directly to the processing source, or they need to connect to a middleman, which is where the Raspberry Pi comes in. So the Raspberry Pi is a Linux environment that we can now install either of Goose or Goose Perception on. So let's say mobile 2, yeah, e.g. Arduino, Raspberry Pi, etc. This video is getting long. I didn't think I was going to take this much time, but yeah. So if we wanted to do that, that could also then connect to this, and then this one connects to the server. And what this means is that we are installing, as an entity, we are installing this processing into either our local computer or our online service. And for this to make any sense, it means that all of it needs to be connected to a central synced memory server. Boom. And that's where the next thing comes in. The memory. The memory is probably one of the most difficult things that I don't think has been solved yet. Memory. Yep. Let me see if I can increase this. How do I increase this again, chat? Large. Okay. So yeah, memory. Now, if you look at this, this is where we are taking input from Bluetooth headphones, smart glasses. Smart glasses contain video and audio. Okay, let's do video and audio. Bluetooth headphones take just audio alone. Audio, smart glasses take video and audio. And then we can also have like a regular webcam connected to the house that just takes video. So with this, our smart device, I didn't put, proactiveness, this perception. So this is its own level. So our smart environment is taking input from either our Bluetooth headphones, our smart glasses, or a webcam, and then takes that into a processing. If we are home, it goes directly into our PC. If we are not home, I'm trying to see if there's a better way to structure this. If we are not home, this goes directly to a server, right? And then that kind of like everything is connected to memory. So this memory could have like a local and online sync. Should be small or medium as case maybe. Large. Okay. So there's local and online sync for our memory. And one of the tools that I felt could do this, because apart from the fact that we need it to be local and online sync, we also need a knowledge graph. Why does this make sense? Because every single day that the model or the tool, AI tool, is kind of like scanning through your day-to-day, storing preferences about you, is letting you know what's up. Every single time they do that, they need to save that file somewhere. But let's say you come back, let's say it kind of stores what you're eating. Oh, this is what you ate for breakfast today, so check for lunch tomorrow, all of this information. And then you come and be like, oh, so what have I been eating? Or if I'm gonna make my favorite food, what would that be? It needs a level of memory and context, because you've not necessarily said this is my favorite food. It needs to find out maybe like your probability, your frequency across different angles of possible conversation that distract you, either from the camera, from what you've said. So building a knowledge graph, e.g. in the way Obsidian works, because Obsidian kind of connects different markdown files and makes sense of them. So that way it already saves the agent like half of the work, where before it does the vector search, the documents or everything serving as the memory is already interconnected in the knowledge graph in a way that they relate to each other. So if you're doing that, Obsidian could fit in that way, but I don't know if Obsidian has an API that if I'm able to structure, if the agent, in this case, for example, perception, as it's learning about me, is creating markdown files. Let's put it this way, markdown files. It's creating markdown files and, excuse me. So markdown files or vector search. So it's creating markdown files or using vector search to know what exactly is going on with my memory. So that's local and online sync. So that if I'm, for example, connected directly to my local PC, that information is synced there. If I'm outside with my Meta glasses, for example, and I'm asking the agent at the same time, maybe connected to a mobile Raspberry Pi, It's also able to sync online to that, what's it called, memory storage. Another thing that comes into play here that we might have overlooked is decentralized web nodes. This one is probably easier, but I don't know, what's it called? I don't know what it would look like if you have decentralized web nodes. You have to set decentralized web nodes. Yeah, that's the problem. So decentralized web nodes, especially if you have them deployed, already provide you redundancy, distributed data sync, all of those things out of the box. But searching might be a problem because you want the agent to be able to quickly get, oh, last 2 weeks I was in this place, so that means I don't want to go to this place. They're just kind of like random information, but like with a knowledge graph and vector search, you can get that information easily from the interconnected files. But with decentralized web nodes, I'm not sure the speed or the efficiency of that will not send you bankrupt, right? And that just reminded me that we probably overlooked an important step, which is like what models would these agents use. So regardless of if this is, let me use this guy, whether we are online or offline, as the case may be, yeah, we need to figure out what our model will be separately. So I used to hear a lot of good things about Grok, but I don't think Grok is the one at the moment. Today, I just saw, there was a mention of, hey, let me see. There was a mention of, I think it's Kiwi. Is that what it's called? Which is like another open source model from what's the word, guys? I'm trying to remember. From Hugging Face? Yeah, exactly. Let me see if I can remember this. I think it's in, let me check my bookmarks real quick. So there's a new one. I can't remember. Yeah, Kimi. So Kimi, yeah. So there's this one called Kimi. Can you guys see my screen? Yeah. So with this Kimi guy, he also has visual agentic agenda, so he can also operate on what he's seeing, he's good with coding, and it basically balances the entire thing, and it's open source. So if you're installing Kimi, right, on your local device, then you basically store all of the processing locally without you being dependent on any third-party server. So let's say models, Hugging Face / Olama. There's Quen. I don't know how good these are in real time, at least today, because these things, they change. I think there's Quen 3 now, actually. There's Quen, there's Kimi 2. Let's see. It's Kimi K 2.5, exactly. There's Kimi K 2.5. There's the free Gemini models, even though that does not necessarily keep you off the third-party servers, that kind of setup. Doesn't really put you out of that. But everything else that we've had so far has been mostly like, oh, this is offline and this is controllable by us. So to recap, just quickly to recap, we have two devices that kind of like power us. We have a local computer. Wait, what's this? Where did this arrow come from? Oh, I remember. My bad. Yeah. So we have a local computer that kind of powers us, but at the same time, we have an online server that processes our requests. So for the local computer, you install open source AI agent. In this case, I'm using Goose, e.g. Goose. Oops. 1 second, e.g. Goose. Because it's open source or open code. I don't know how customizable open code is, but it's open source as well. So either of those two, because they're free to use, you can use that to like customize the UI. So if you customize the UI where you speak and all of those things, and it's doing all of those graphical sci-fi things, that's your control. And then proactiveness, you need Goose perception, or maybe as well skills, right? Because yeah, next thing for proactiveness is, what's going on here? No. So we have Goose perception, we have skills / MCP, depending on how you want to go, or even both, / or plus MCP, whatever. And this also kind of like connects you to platforms. So proactiveness plus connection. Yeah, let me call it this way. Proactiveness plus connections will give you Goose perception and skills plus MCP. I already explained what perception was with this graph for anyone that missed out, and also kind of explained skills. So skills and MCP servers kind of help you connect this your AI agent into tools that you already use. So let's say your Slack, your Google Maps, your email, your calendar, so that if you're speaking to this agent, they have access to this data from all of these sources. So you can proactively install services that you need. But this is where Goose Perception also comes into play, because Perception has a bunch of, in this case, it's built on Goose. So it has a bunch of Goose recipes. Let me see if I can zoom in here for you guys to see. So if you look at like, it's able to handle meetings, track your emotions. Let me see, there's any observers here. Yeah, it's able to check out background tags, check your Chrome history, all of those information, your interests. This is storing and tracking information about you, so that by the time you need to ask something back, it has structured it in a very nice way. The only question was for you to continue optimizing the save space and also the speed of search. That's where the kind of like Obsidian or some knowledge graph starts to come into play. I might be wrong about that eventual execution, but something like that. I feel like we're going, okay, let's see, where are we? So, speaking to this thing will be from our, maybe from our mobile glasses or any kind of like Bluetooth headphones where we're connected via Bluetooth either to the PC, or if you want to stay mobile, we have like a Raspberry Pi and we connect it via Bluetooth. Bluetooth is very key in this case, so that we can speak wirelessly to any of the devices that we choose, Raspberry Pi or a PC if you're around. And then the models serve as, can you guys see this? Yeah, and then the models is what does the processing. We need to use free and open source models that we can run on the local devices. I don't know if we can run, that's true. I don't know if you can run Kimi or Coin on a Raspberry Pi. Depends on the RAM, and RAM is pretty expensive these days. But it just gives us a picture of what this could look like. And then from there, if you're able to actually get the connection and the running going properly, then we start to worry about one of the most important things, because context is king. But while you can give an AI agent context about what you are doing right now, you need to be able to have context about you in general, like things you did for you in the past, your calendar, all of those things almost in real time. And you need to be able to search that very fast, which is where knowledge graphs came into play. And then we have DWN so that you can distribute and store it and do it like encrypted redundancy so that you don't lose your information because your computer crashed or something like that. Let me see, is there anything else I'm missing? Yes. So now for the input, we need models that can process both. Let me see. We need models that can process both the visual and oh yeah, I should probably put it down here. We need models that can process visual and audio cues and audio inputs. Because we are expecting this AI to see or hear you, not just typing. We are actually like acting in real time. So stuff like 11 Labs could also come into play here as a tool. Let me see. I think 11 Labs is here. Stuff like 11 Labs will help you deal with like the processing. So if someone is speaking, you're like, oh yeah, this is what it's trying to say. This is what we need to do. If it's a picture, this is what it's processing to get it done. But a bunch of those are already kind of like embedded into Goose Perception as well. So you get to like, it sees your emotion, for crying out loud. It sees your emotion, it sees the tone of your voice, it knows what you mean, and then it acts according to that. Let me see. I think for a start, that kind of like describes what this overview will look like. And in terms of like, what do we need? It would be more like, oh, okay, so requirements. Let me zoom into this real quick. So requirements would be like a local PC that can run pretty good actually. You can have a Mac Mini and all of those things. We need a mobile mobile. What do they call a Raspberry Pi? What's the official term for Raspberry Pi? Mobile. Let's just say mobile computing device, e.g. computing device, e.g. a Raspberry Pi with Bluetooth connection. Why is this taking so long? With Bluetooth connection. So now the question is, do I even run I can run the model as well. So in Iron Man, I think it's Civil War or Age of Ultron, you realize that Friday, Jarvis, everything was like on a disk, and that's because the logic and the context of it is all installed as a package. So the processing, the parameters, the configuration is part of that package, and it can be installed on as many devices as possible. But the context, the memory, all of those things are installed on a third-party server, on the stack server, as the case may be, that they can always access. So we need memory server for uninterrupted access. And then after that, we need input devices. Yeah, wireless input device. So that could be Bluetooth, that could be any other kind of technology. So we have wireless input devices. We have wearables, headphones, glasses. I mean, that counts other wearables, but you get the drift. Let me see. Oops, nope. Yeah, so we have that, and then we have, what else do we need? Yeah, so once we have this, we install and customize agent, open source agent, plus models as packages on devices. So we install and customize the OSS agent once we have that project, we deploy it to the local PC, we deploy it to the mobile computing device like the Raspberry Pi. And with that, I think we have basically, this is a very subtle setup system that you can scale as you go, if I remember correctly. Let me check my notes if I'm missing anything, because first of all, we need to be able to have like speech recognition. So those are the models that we have that can have visual and audio input. So that handles speech recognition, it handles natural language processing, it handles text to speech, and then it's also able to do function calling. So with those function calling, that's where it's going to like MCPs to be able to actually carry out a task, send an email on your behalf, book a flight, all of those things. The categories are the same, just that you have to choose a model that actually qualifies to any of those things, so that you can also have conversations with it. So it's speaking, you can interrupt it, stuff like that. So a capable PC is required, a mobile device, like we said, maybe like a Raspberry Pi, or sometimes maybe even your phone. To be honest, yeah, I think I skipped out on that. Or your phone could suffice. And then with that, I think we'll also need so voice output. If it's working with your wireless device, with your wearables or your glasses, most of them have like wireless speakers, so you can basically hear back. If you remember Iron Man 3, where he was fighting with the guys with the extremists, you can see he was speaking via his earbuds, because it's not magic, guys. It's not magic. Jarvis is not everywhere. He needs to be able to connect wirelessly to it. And I think that's, to be honest, that's the most important part, because everything can then be handled by MCP, which is Model Context Protocol. We have Cloud Skills today, which is applying to almost every agent. And then with that setup, we have something that comes close. Yeah, we have something that actually does come close to what you would call Jarvis. Yeah. If I spend some more time, if I wasn't talking in real time, I'll probably kind of flesh this out. I'll probably do that now that I have this image. I'll probably take a screenshot of this image as well and share it on Twitter and see if we can start diving into it. I'm probably missing a few things, but regardless of that, yeah, this is what I would attempt to start building on to make something like Jarvis today. Thank you guys for stopping by. I'll see you guys in the next time that we're doing Building with AI and Office Hours with Ace. So, take care, everybody.